Up to this point, we have not seen a lot of reactivity in the benzene or aromatic ring, and that could give you the false impression that this functional group is completely inert, which is not true. In the remaining lessons, we're going to see that the substituents on benzene rings can undergo a substitution reaction which an incoming group Y replaces X to make a new carbon to Y bond. Just to remind you of where this falls in terms of other kinds of chemistry that we've seen, this is yet another example of the substitution reaction where we're dealing with sp2 hybridized carbon of the aromatic ring. From our studies of carbonyl chemistry, we know that it's possible to do substitution chemistry at sp2 hybridized carbons. In that case, we learned about the nucleophilic acyl substitution pathway. For substitution at benzene rings, it turns out that no new elementary steps are going to be needed, but the pathways will be a little bit different. We'll first encounter the most common type of substitution, which is known as electrophilic aromatic substitution, and this is the case where the substituent that's being replaced is a hydrogen atom. In addition to the most common pathway, the electrophilic aromatic substitution pathway, there are 3 other types of substitution that we'll encounter. And in this webcast, what I'm going to do is briefly introduce you to these 4 different kinds of substitution chemistry that we're going to be encountering over the next several lessons. Let's take a look first at the electrophilic aromatic substitution pathway. Here's an example where we just have benzene. The hydrogen atom in this case is replaced by the nitro group, which comes from nitric acid. In the next case, we do a nucleophilic aromatic substitution in which the chlorine is the leaving group and it's being replaced by hydroxide to make this phenol. This reaction, as we'll learn, is very similar to the substitution reactions at the sp2 hybridized carbonyl carbon. The next example, the third case, begins with the very common functional group known as aniline, in which the benzene ring has a nitrogen attached to it. Under conditions of what are known as diazonium formation, we end up transforming this amino group into a diazonium salt, an arene diazonium salt. This is a very good leaving group. It can leave, the neutral nitrogen is lost, and now a nucleophile, in this case water, delivers the hydroxyl group of phenol. And so we'll learn about this as the third type of substitution, where overall there's been replacement of the amino group for a phenol through a diazonium intermediate. The last type of substitution is a little bit strange because we're going to be replacing a chlorine with a nucleophilic group, and so it looks like a straightforward substitution reaction. But notice that in addition to replacement at the carbon which bore the chlorine, there's also substitution that takes place at its neighbor. The hydrogen on that carbon has been replaced with the amino group, and the hydrogen seemingly has moved over to the adjacent position. So we'll learn about this 4th type of substitution mechanism that involves the benzyne intermediate. And so the main point that I want to leave you with is that the benzene ring is reactive, and it's capable of undergoing substitution by at least 4 different pathways.